Hey there, micro friends. Welcome to another episode of Let's Talk Micro. As always, I'm so happy that you're here with me. And if this is the first time you're listening to Let's Talk Micro, well, thank you for choosing it as one of your podcasts. Well, as promised, here it is. Today's episode is the live episode we recorded at ASM Microbe. And this happened in June, and it was such a great episode. And I'm so happy that a lot of people chose to attend the episode. I'm so grateful for your support. And in the episode, I was joined by Andrea Prinzi, and the guest was Dr. Nathan Ledeboer. And the big question was, what can whole genome sequencing tell us about AMR, antimicrobial resistance? And one of the questions comes from, we get a lot of information from whole genome sequencing, and we get, some genes that confer resistance. So, can we use this information to predict antimicrobial susceptibility testing? And this is such a fascinating topic, and it was such a great conversation. So, once again, thank you, Dr. Ledeboer, for joining us. Thank you, Andrea Prinzi, and thank you, everyone, once again. So, let's go ahead and listen to it. Good afternoon, everyone. Welcome to the first live episode of Let's Talk Micro right here at ASM Microbe in Washington, D.C. Today, I'm joined, by my co-host, Dr. Andrea Prinzi. So, Andrea, how are you?
I'm doing great. I love doing this podcast. I don't know if for any listeners out there, it's been a little while since I've come on and helped support. So I'm really happy to be here at ASM with you. This is fun.
It is great having you. And those of you that have been following and listened to the Let's Talk Micro AMR section, I know we haven't done an episode in a while, but
Sorry.
we'll try to get there. We went over the organisms, so eventually we'll get to mechanisms. So just stay tuned. As a bench microbiologist, sometimes we hear about whole genome sequencing, and of course we perform antimicrobial susceptibility testing. And maybe as I talk to people, this is a topic that maybe we don't know much about. So I thought it would be a good time to do an episode about it, and as an extreme introvert, what better than to do it in front of an audience, right? I have to fight my demons and, get there. So my guest today is Dr. Nathan Ledeboer. Dr. Ledeboer, welcome to Let's Talk Micro.
Thanks for the invitation. It's a pleasure to be here and a pleasure to be at the first live version.
It's such a pleasure having you. So normally here on Let's Talk Micro, we start with a quick introduction. So maybe we can start with that. Tell the guests what you do and anything else that you want to share with them.
Sure. So I've been a clinical microbiologist for almost 20 years. So I did my fellowship at Washington University in St. Louis, and I've been practicing at the Medical College of Wisconsin since then. Day to day, I've become more and more of an administrator than I have a clinical microbiologist. I don't know if that's a sentence or a good thing, but I've spent a good chunk of my career really working on trying to advance susceptibility testing systems, to bring them into the modern era, to adopt new technology into those systems, and to really and ultimately deliver faster care and better quality care for the patients that we serve.
So this is, I'm not trying to call you old, okay? But you've been in Clin Micro for a long time, or a good amount of years, and you've seen a lot of technology come through. What sparked your interest in whole genome sequencing in Clin Micro?
I think probably my watershed moment, if you will, for next generation sequencing was I was reading a paper, and they were talking about two patients that had Mycobacterium tuberculosis infections, and both had failed therapy despite phenotypic susceptibility testing, telling them that the organism was susceptible. So they went and sequenced both of these bugs, and they found that in one of the bugs, it was about a 10% of the population had a isoniazid resistance mutation. What was even more fascinating was in the second patient, they found a subpopulation that represented less than 1/100% of the population that was resistant. And that clone ultimately replicated as the patient was being treated, or was selected for as the patient was being treated. And that ultimately caused treatment failure in that patient. And that was really the watershed moment for me to tell me, and that really showed me this is what this technology can do. And it can help us to address one of those very basic limitations with phenotypic susceptibility testing. It can find those small subclones and can really help us to pick those out so that we can avoid treatment failure.
I love that.
Yeah, and this is something that I say constantly, there has been a lot of change in micro. Even for me, that I've been doing this 10 plus years. I started in the pre-moldy tough days, right? Where
Same.
sometimes you have to wait till the next day to get that ID. Sometimes you have to send it out, and unless you printed a label or remember the name, you never found out what it was. Now you have moldy, you're doing gene sequencing and getting all these names. So it's a very exciting time to be in microbiology. We're learning a lot. Of course, as the lab evolves, right, there's always challenges on bringing testing, and whole genome sequencing is not a stranger to that. So maybe you can tell us what are some of the main challenges of bringing, gene sequencing to the lab.
So I think there's a lot of challenges when it comes to bringing gene sequencing into the lab. I think one of the things, if we harken back to the pandemic, that the pandemic really showed us in clinical microbiology is we have whole scale embraced automated molecular technology. We love our fully automated molecular testing systems, our sample to result testing systems. But as the pandemic showed us, when we didn't have test cartridges that were available, we forgot a little bit about the basics of how do we do molecular biology. In our laboratory, we started doing manual PCR testing, and our techs were like, what is this? Why are you making us do all of these extractions? And why do we see this contamination? So I think one of the biggest challenges with next generation sequencing is we have to go back to our roots, and we really have to remember how to do molecular biology. What are those good practices that are associated with it? Because today, as the technology currently stands, NGS is going to be a bit more manual. We're going to have to do extraction. We're going to have to do library prep. We're going to have to put it on the sequencer, and then we're going to have to do all the bioinformatics. So all those manual steps are things that we're going to have to get a bit more used to, at least for the medium term. The second big challenge, and this is a major challenge, is bioinformatics. Many of us who aren't old but have been in the field a while, Andrea, we're never trained as bioinformaticians. So learning how to do bioinformatics and learning how to use the tools is a challenge. Again, I think technology is going to solve that over the next couple of years. We're already seeing algorithms being developed and software packages that are being developed that will help us do a lot of that analysis, that will automate that analysis. But I think as we start to really get into AST testing, when we're not just identifying an organism, but we're identifying individual point mutations, I think there we're really going to need advanced tools to be able to help us identify those, and then using data that exists from phenotypic AST help us to correlate that. So I think being comfortable with bioinformatics, being comfortable with some of the tools that are available, and then being comfortable with the data is going to be critical. The other thing I think that we're really going to have to deal with is today when we have a mixed culture, we just look for different morphologies, right? We pick those different morphologies out of the culture. Well, when you're doing sequencing, you'll get different identifications, but then how do we associate that point mutation? How do we associate that beta-lactamase with an individual organism so that we can use that to help direct treatment? So we're going to have to be comfortable with the depth of sequencing to make sure that we are adequately able to separate that as well. So there are both technological challenges that we're going to have to overcome, as well as software or analysis challenges that we're going to have to overcome as we start to use this more and more, especially as we go into the resistance determination or the detecting resistance space.
This actually launches a bit off of several of the things you just said, but I think, when you talked about how different this is than traditional phenotypic AST, or even just some of these other methods we have where you get a single, gene called out. What kind of information are you getting from sequencing in terms of AMR, AST? What information is coming out of sequencing that's related to that?
Well, I think it's important that we acknowledge not all sequencing is created equal. So you have different approaches to sequencing. So I've seen posters at the meeting here where they're using a probe-based approach using NGS in order to detect mycobacterium at very, very low levels. We're talking 10 to the 1.5, 10 to the 2 range, directly from a clinical sample. Probes give us that tool to really increase that analytical sensitivity, but they limit us in terms of the depth or the information we can get because we don't have the whole genome sequence that we can map. If we're going to be doing whole genome sequencing, then the question becomes, Are we dealing with an isolate that we're sequencing, or are we dealing with a patient sample? Because there are different challenges that we have to overcome in that space. If we're dealing with an isolate, finding individual SNPs and associating them with individual genes is easy, relatively easy, and doesn't take a whole lot of sequencing depth. If we're coming out of a patient specimen where 99% of the patient of the specimen or the specimen that we're sequencing is human, we first have to find a way to dehuman that, and then to enrich for the microbial signature, to then be able to get to an ID, and then probably sequence even a little bit deeper to get to resistance information. Again, presence or absence of a beta-lactamase, presence of a point mutation, and then we'll have to think a little bit further of how much farther do we want to go, and what other sequencing tools do we want to employ in terms of what information are we trying to get out of that specimen.
Sounds like that's part of the challenge as well, as like the variability there in approach, right?
Very much so.
Yeah.
Yeah, and just a quick comment, circling back to the bioinformatics, it is a dense topic. I do recall when I took a class on it in grad school, and it was, it was challenging, but, thankfully this community is made of very bright, hardworking, smart people that are up to the challenge. We kind of discuss what information we can find, and in the lab we're not strangers to we test from some markers. We do it with your typical blood culture. We do it with isolates, but now we're doing the sequencing. We have all this information, right? So, can this information, be used to predict susceptibility? And if so, how do we get there, and how would it work?
So, about 2 years ago, Romney Humphreys, together with Paul Rhodes, published a paper in the Journal of Clinical Microbiology that for the very first time took a whole genome sequencing approach to isolates. And they said, what can we find for resistance, and how well does that correlate to phenotypic AST? So they were able to do whole genome sequencing, so got the whole bacterial genome. And then they were able to look for point mutations. They're able to look for other genetic markers for it. And it was surprising just how high of correlation they saw. In many cases, again, they looked at it compared to cefepime, which is not an easy drug to predict. And they found in many cases upwards of 90, 95% accuracy using the genetic information in order to predict whether that isolate would be phenotypically susceptible or resistant. To me, that was nothing short of amazing that they found. We've seen other studies that have been published since then looking at other drug bug combinations. There are certainly still bugs that we don't have as good of genetic data on in terms of what's causing the resistance. But that paper, I think, was really nothing short of fantastic in terms of what they were able to show.
Is that kind of application being used in the clinical micro lab right now, or is it still kind of uncharted territory?
I think we're starting to see it used in the clinical microlab today. Less in routine bacteriology. I think probably one of the first and easier places to go is going to be mycobacteriology, especially TB. We've got really good data today around the mutations that are associated with drug resistance in Mycobacterium tuberculosis. We also know that a genomic approach is going to be substantially faster than phenotypic approaches. And oh, by the way, we also have the challenge in mycobacteriology where the phenotypic approaches that we use, in some cases, we have commercial systems that are either on permanent back order or being removed from the market altogether. So I think there will be some market forces that are going to push us really to doing it more in TB. So I think it's actually going to be routine process, especially in the US, Europe, for doing TB genetic or susceptibility testing will be a genetic-based approach. That'll be, I think, one of the first. Well, actually, virology has been the first. But I think in bacteriology, that's going to be one of the first areas. And it really, even with a couple of days to get your sequencing results, it's still a substantial shift forward in the field in terms of reducing turnaround as well as providing data that's accurate back to our clinicians.
Sure. Yeah.
And when it comes to we already talked about some of the limitations and challenges of gene sequencing. When it comes to using this, applying this to like AST, what are some of those limitations or challenges to this type of application?
Well, I think the biggest challenge today is all of this work is still being done in the lab developed test space or in the research use only space. We have not seen as much movement as I had hoped in terms of getting FDA cleared solutions in this space. I do think that within 1 to 2 years, we will have a couple of FDA cleared NGS based tests, both direct from specimen as well as from isolates. So I think the regulatory process has slowed things down a little bit. Bioinformatics and the challenge of bioinformatics has really slowed this down a lot too. Again, I will say, when I hear the word bioinformatics, I get scared a little bit and I kind of try to run away from it. But I think that there are tools that are available that are going to make this so much better. The other place that we've seen a ton of advancement in, and the early advancement has been happening in oncology, but we're starting to see it come into infectious diseases, is in the data tools that are available in our healthcare information systems to both analyze this data, reanalyze this data, and to use this data to its full potential. So we've seen for the very first time this year, Epic, for example, has actually developed a genomic data repository that's a part of the electronic medical record, meaning you can take either FASTA files or you can take more semi-analyzed data, upload it into the electronic medical record so it can be analyzed by just about anybody. You can imagine, not only from detecting resistance, but also from the perspective of epidemiology, how powerful that can be. Because now, instead of identifying a drug-resistant clone based on, I've seen this patient, and this patient that have a carbapenem-resistant Enterobacterales infection, now I can actually have my electronic medical record prospectively look at that and alert me that we have these 3 strains that are circulating. And oh, by the way, based on the sequencing data, we know they're related, 99% chance. We probably need to initiate an epidemiological investigation in terms of what's the link to this and how can we stem that. So there's really a potential with a lot of these advancements in how and where the data is stored to actually do epidemiological work on a prospective basis rather than retrospective.
Okay, now I'm really inspired by that response, and I'm thinking, 5, 10 years from now, what does this landscape look like in terms of sequencing for AST or AMR? But maybe not only in the clinical microbiology laboratory, because I love what you're saying here. Like, what does this look like 5, 10 years down the road from like a larger systems perspective even?
So I think I think this emphasizes so many of the practices that we currently do. It brings pharmacy and microbiology closer. It brings epidemiology and microbiology closer. It brings infectious disease and microbiology closer. It also means that, so when you think about this from a patient perspective, you have a patient laying in the ICU. You complete your sequencing of the blood specimen that's sent down. You identify the organism as an E. coli, and there's an NDM5 that's present. That's going to speed things up, but it also means we're going to need to think about how do we educate our ICU providers so they know what that means. And I think it's going to substantially increase the role, the consultative role that the microbiologist has with those care teams that are taking care of those patients, because we're going to have to convey this information at 2 a.m, at 8 a.m, on the weekends, on holidays. And that really emphasizes the importance of microbiology in that space. It also means, though, for those of you that are, quote unquote, earlier into the field, we're going to depend upon your bioinformatics knowledge and your knowledge on this. And for those of us that have been in the field a little bit longer, old dogs are going to have to learn new tricks as well. Really being ensuring that we show our utility.
That's great.
And I just want to say, for many of you, you probably don't fully understand how big of a challenge this is going to be. So if you think about an academic hospital, say pick out a 1,000-bed academic hospital. On an average night, after everybody's gone home, after all the consultation services have left, there will be somewhere between 2 and 4 licensed physicians or APPs that will be caring for every non-ICU patient in that hospital. So think about that. You may have an individual physician or APP that's caring for 200 patients that night. When you call them with that result, they've got a minute to talk to you. So it's going to be critical that you understand, how do I convey that in a way that A, they understand it, and B, that they act upon it. And we've had a lot of really good lessons over the last 15 years or so in involving pharmacy and involving our antimicrobial stewardship colleagues to really help us, because not only now can they convey information on the test result, they can convey it on the treatment result too. So it's really going to require we rethink how we communicate information and making sure that that's useful, not only to the experts, but to the people that are actually providing the care day to day.
Yeah, it's very. Thank you for bringing that example and put it into perspective. And we in the microbiology field, we're also used to, being overwhelmed, and that's one of the challenges that we have in the profession. And sometimes it deters people from working in the department because they say, I never get to go home on time. The volume is so high, and plus, the little thing that smells, but that's something else. They can never get past the smells. But micros, it is a busy place. So that example, it brings it into perspective that, with 200 patients, that's a lot. We mentioned earlier how much has the field changed over the years, and it's even, very impressive, even to me, like just, it's like thinking from like the regular cord phone to now where we have gone in micro, all this manual tests, and now we're talking about gene sequencing. Sometimes, there's the talks of AI and things like that. So as we start thinking of this, a lot of the technology that comes up and advances, right? They're complementary to your tests that we already have in place, right? They don't replace them. So when it comes to this application, do you see it as, remaining complementary, or do you see it as eventually replacing it?
So it's a great question. And I think certainly for the foreseeable future, it will remain complementary to what we currently do. The other thing that we have to acknowledge, and this is much more of a US problem than it is ex-US, but it's still a problem worldwide. The 800-pound gorilla in the room is reimbursement. And how do we get paid for any of this? Today, I want to send a respiratory panel that costs $120, and I want to bill an insurance company for that. I'm not going to get paid if it's more than 5 targets. How are we going to get paid for a technology that costs us $500 or $1,000? So we're going to have to figure out some of the payment models. We're also going to have to figure out, maybe we at least start using this technology where it can have the greatest clinical impact. So maybe on our inpatients, maybe in patients that are immunosuppressed, that are at greater risk of infection. So the reality is we're going to have to use complementary technologies, at least for the foreseeable future. It's also important that we recognize, despite the fact that MALDI-TOF was implemented or was first made available in 2009, over half the clinical labs in the US today don't have a MALDI-TOF. They still rely on biochemical IDs. That's in part due to volumes in smaller labs. It's also due in part to lack of expertise in those labs. So the field will transition over time as well, because we will have variable adoption of the technology. We've got a lot of emphasis today on rural health and bringing quality care to rural health. How do we train a generalist that's working microbiology today, chemistry tomorrow, in interpreting sequencing and performing sequencing? How do we ensure that those patients aren't left behind? So that's also going to be an area where we really have to be very diligent in making sure that we address those needs or those underserved populations using this technology as well.
Yeah, that you bring that point, and that is something when it comes to, I have worked in different institutions, and it is challenging. Yeah, if you're working in a lab where you're trying to read plates or do blood cultures and then go run the chemistry analyzer, and QC's failing, and you have to calibrate, or even in the same micro set, like during COVID, I was working in a place where you were reading plates and also at the same time you were getting COVID tests. So I felt like my brain was just splitting apart. I'm looking at one plate, run a test, and come back and forth. So that's something very real. Yeah.
Yeah, this is my last question for you, but I was excited when I saw you were our guest today because this topic, and then knowing that you oversee really a system that includes a lot of rural care, and we know that the structure of healthcare consistently changes, and we've seen these different models where you've got maybe like this hub and spoke kind of situation or what have you. And I just have a lot of questions about. I'm a microbiologist that's also a clinical outcomes researcher that works in an innovation space and industry, and we're always thinking about access issues for many of the points you've already brought up. But I always wonder, technology like this, which requires such a big lift in terms of expertise and the infrastructure you've already mentioned, what does it take to get something like this to communities that need it very much?
Well, I guess here's the advantage of having been in the field for a long time. When I got into this field and I took my job at the Medical College of Wisconsin in 2007, most molecular testing was limited to reference laboratories and large academic laboratories. Why? Because we had the same problems that we're having today with sequencing. We didn't have the expertise in those locations. The instrumentation was too expensive, and folks felt like it was never going to come to those spaces. What we've seen through technological advancement is today everybody does molecular testing. Everybody can have a point of care molecular test system in their laboratory. It doesn't require an expert in molecular technologies to do it. So I think technology is going to take us a long ways to helping us serve those populations. Eventually we'll get to a point where we may even have a CLIA waived version of a sequencing device where it's as simple as putting your blood specimen on, let the instrument take over, it will do the bioinformatics and spit out a result. Or maybe as an interim step, the instrument will take over, will do the work, it will digitally send the information for analysis down to the central lab. Central lab can kick results back. But it's really important to think about those kinds of facilities. And I'll just give you an example. I visited one of our critical access hospitals in central Wisconsin about 2 weeks ago. So the size of this hospital is about the size of the area that we're in today. They have anywhere from 0 to 8 patients that are there. And at most you'll have an ED doc, many cases an APP that will be there, a nurse, and maybe a lab tech. The lab tech in there does everything. They do chemistry, they read hematology smears, they do limited microbiology. I mean, the ideal place would be we could put a CLIA wave sequencer or even a CLIA moderate sequencer into that location. And that blood smear, or in that blood specimen, instead of having to get shipped down to the central lab for analysis, could be done right there. That is transformational in terms of how we provide care to that patient, because we can then keep that patient in their community and we don't have to require that they be transferred, and we can improve their outcomes. And just to kind of close on that thought, we just got done with a 22-month study in our facility looking at outcomes associated with a novel diagnostic to predict sepsis. These technologies can change lives. When we did this study, we're showing when we use this new technology, a 2-day reduction in length of stay and an overall 1-day reduction in the time that patient is in the ICU. I'm confident that doing sequencing detection, especially for things like bloodstream infections, will have similar outcomes to that.
That's great.
Yeah, that is you mentioned that lab and you just brought a memory that I'm definitely done with those days. I do remember a time in my life I will never miss. You're doing a cross match, you have a CSF that you have to do a gram stain, you have a baby CBC. It's just all over the place. It's so intense. Well, as we start wrapping the episode, I always like to end on a lighter note, right? We share some good information. So I like asking guests a question that the answer is fun. So we all tend to have a favorite book. Or least favorite, that's also valid. Either because most times people work with it in school, or it could be like a pattern, or the way that it looks on the plate, a smell, anything. We all have our favorite book. So, Dr.
We don't smell our plates, though, right?
We're not supposed to smell plates, right? But we all get those, right? We open those incubators, and sometimes that nice myroides hit us, and we go back to having that great day. It's not only cold, I have something exciting in there. So we get used to those. And by the way, Pseudomonas aeruginosa smells like grapes, not tortillas.
It's tortillas. You're wrong.
Well, I
So
guess,
so what's Nate's favorite bug is the question. And what does Pseudomonas smell like?
yes.
So Pseudomonas definitely smells like grapes.
Oh my.
For 100% grapes.
I strongly agree to disagree with you. I'm sure it's a genetic thing or something.
And I'd have to say, I think my favorite bug has got to be Stenotrophomonas multifida.
Okay.
Largely because it just says to all the antibiotics out there, I'm going to destroy you. And it's such a challenge to treat clinically. And it's also a challenge to think about as a clinician. Is this significant? Is it just an environmental organism that's there? So the fact that it continues to trick us just continues to intrigue me with it.
I love that. Love that.
Well, Dr. Ledeboer, thank you so much for taking the time to be in Let's Talk Micro, especially on this live episode as being our first guest. And to the audience, as always, like to say when I'm closing my episode, continue bringing that passion to what you do. It's so important. You do such great work. And as always, stay motivated, stay safe, and of course,
Keep talking micro.
Yay.
live from ASM. Thank you so much. Well, friends, that was the episode. I hope you enjoyed it. I had such a great time recording this episode, and it was such a great experience to be able to do an episode in front of a live audience. So, thank you again for those that attended. Thank you, Andrea, for co hosting it with me. And of course, thank you to Nathan Ledeboer for being a guest. And this is such a great topic. And as the summer continues, what a better way than to end season 5 of Let's Talk Micro with this episode. So, after today's episode, we'll take a break until August. We'll come back with new content as we always do. It's always good to take a break to recharge, work on content. And it is also a great time to go back and revisit some older episodes. Maybe you missed a few. So, it's a great time to go back and do that. But those of you that maybe have been listening for a while, maybe you know that Let's Talk Micro turned 5 in May. So we have been doing this for 5 years, over 200 episodes, over 225,000 downloads. So as always, I'm so grateful for you for listening. So thank you again. And hey, you can find us on any podcast platform. So we are on Amazon, Spotify, Goodpods, Apple. We're right there. So please subscribe to the podcast, download episodes, and if the app allows you to do so, please leave a review. Thank you so much for the support. As far as socials, you can find us on Instagram, TikTok, YouTube, Blue Sky Social as Let's Talk Micro, on X as Let's Talk Micro 1, LinkedIn as Luis Plaza. And there's an email address, which is letstalkmicro@outlook.com. And then there's a website, letstalkmicro.com. In the website, you can find information like study resources, licensing information, episode updates, and more. So, either via social media, via email, via the website, you can provide us any feedback, any topic suggestions. They are always welcome and appreciated. If you want to support us in any way, you can do so via Venmo or via Buy Me a Coffee KOFI. Both links available on the show notes. And friends, you know, if you're part of the microbiology infectious diseases community, the learning about antibiotics can be very difficult and challenging. So, if you are looking to learn more about antibiotics, please check out www.learnantibiotics.com and the Learn Antibiotics book available on Amazon. These resources include cheat sheets, practice test games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. And as always, these are some great resources from Dr. Timothy Gauthier, a very passionate pharmacist. And the Let's Talk Micro podcast is supported by the American Society for Microbiology. To learn more about microbes, visit asm.org. And that, my friends, is the end of this episode. I hope you enjoyed this content. As always, I enjoy sharing this information with you. And what a great way to end the season, which is season 5 of Let's Talk Micro. As I said earlier, we'll return in August with new content. But as always, I'm so grateful to you. and maybe now take the time to share episodes, go back to older episodes. Anyway, a lot of great information. So, thank you. And please continue bringing that passion to what you do. It's so important. You do such great work. So, enjoy your summer. Hopefully, you're traveling, you're spending time with family, with loved ones, with friends, doing fun stuff and recharging that battery. So, we'll see you in August. And as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time, bye.